In the previous session, we learned how to interface a DHT11 sensor with the Raspberry Pi and read the temperature and humidity data. The data which is read from the sensor was simply displaying in the terminal in a continuous loop in the previous example. In this example, we have made some improvements to the previous program. The circuit is same, so I am not explaining about it again. Here, what we will do is, after getting the data from the sensor, we will upload that to the ThingSpeak server. We will create separate channels for that, for temperature and humidity respectively. We will upload the data to the ThingSpeak for getting a graphical representation of the data. So first we need to create a account in the ThingSpeak, and it's free. So we can take the ThingSpeak website now. I have already created an account. So after creating the account, we have to create a new channel. So click on the channel. I already have two channels, but I will show you how to create a channel. Click on the new channel here. And after that, we need to give some name. I am giving a sample name here. Description if anything if you want to give, otherwise it's optional. And field 1, you can give any name for the fields, but as it's good to give some meaningful names. For first field we will give as temperature, and for the second field I will give as humidity, because these two are the parameters we need to send to this ThingSpeak server from the Raspberry Pi after reading from the DHT11 sensor, right? Okay, so after creating these two fields in the new channel, we can click the save channel button here. After that, go to the channel settings and save this channel ID. You can see a channel ID with a number. Save this channel ID number, and after that go to the API keys tab and save this write API key. This key you need to save this also, because we need these two things in our program later. So that's it with the ThingSpeak website. First we need to create an account, then create a new channel and the corresponding fields. After that you need to note down the API key and the channel ID. That's it. We can minimize this, and now one thing before writing the program is you need to install one more library here. That is a library for ThingSpeak, and the command is this. That is similar command is similar actually. That is, we can install with pip. It's pip3 install ThingSpeak. If you are coming from the previous example, you need to install only this one extra command. If you are doing this experiment as a fresh one, then you need to install all three libraries. The first one is for the DHT11 sensor. Okay, now we can see the program. So this is the program. Here we have made the program a little more structured. You can see that we are calling the main while loop from a main function. In the previous example, we have not used anything like that. We simply write the program one by one. So here I have written it in a more structured way. So everything is within functions, separated with the functions. There is a one main function. It is a structured way of writing a program in Python. There will be one main function, and its syntax is like this. And inside this one first main function, we are calling that while loop. And from the while loop, we are calling another function. That is the function named measure. And it is from this measure function the parameters from the DHT11 sensors are reading continuously. And this program is similar to that of the previous one. And you can see this line. This is the extra line we have added in this program. This line is the one in which the data is getting uploaded to the ThingSpeak fields that we created. This line with this line. The above line is similar to the previous example. This simply write the program in the terminal, data in the terminal. That is the temperature and humidity data. And this line, the channel.update line, uploads the data to the ThingSpeak server. And here you have to notice that the channel ID, that is the one we have saved from the ThingSpeak website. The channel ID you have to give here, and the write key we have to paste here. You can simply follow this format. I will give this program in the description section so that you can copy it from there and use in your program. This is the program. I have already written the program in the Raspberry Pi, and we can save and exit that, and we can now try running that. Python space DHT11 ThingSpeak.py. This is the name I have given for this program. And Python, I am going to execute that now. Okay. So like the previous program, it will also show the temperature and humidity in the terminal also, and at the same time the same data will get uploaded to the ThingSpeak server. So we can wait for a few minutes so that the ThingSpeak server can form the graph with this data. We can check the website now itself, my channels, and you can, depends upon which channel you are using, you can use that. We can click on the public and you can see that today the date is March 2nd and the temperature is plotted in the graph, and humidity temperature is 27. Today the date is 2nd, yes, correct. So temperature is 28, last temperature we got here is 28, and humidity is 41. We can check on the 28 and 41. So the data came here is exactly the same we are getting in the terminal. So we have successfully uploaded the same data to the ThingSpeak server. If you check the graph, after a few minutes it will get populated continuously, and you can edit the different parameters of the graph and set it according to your needs. You can click here, there is an chart options button link here. You can click here and you can set different parameters here. You can set the x-axis minimum, y-axis minimum, and time scale average. These are all options you can set according to your need. So this is how you can upload data from a DHT11 sensor to the ThingSpeak server via Raspberry Pi. You can try this program in your lab. The actual circuit is same as the previous one. That's why I have now discussed here again. So you can try this in your lab, and if you have any doubts, you can comment below.